there is a boy walking along this ground. He walks this way, and he walks for some distance until he's here. Okay, and after that, he turns back and he walks backwards until maybe about there. So from here to here, okay, let's say it's 2 meters. And let's say he took 4 seconds to walk this distance, and from there backwards, let's say he walked, let's say, right, it's 1 meter, and let's say he took 1 second. Okay, now let's try and plot a graph of this. A graph for, say, the distance that he walked. So we could imagine, see, drawing the axis. Let's say this is the time. This is the time in seconds, right? And let's say this is the distance. Okay, I'll call that distance in meters. Okay, now after 4 seconds, okay, we know that. Okay, right, let's start from the beginning. Let's say that we take that as 0 distance in the beginning. I can even think of this as the x-axis. Alright, let's say in the beginning is here. So at time, this is the start time, alright, when t is equal to 0. So on the graph, he would be here in the beginning at 0 time, 0 distance. And after 4 seconds, he is he's at 2 meters away. So right, let me put some ticks on the graph. Let's say this is 1, 2, 3. So that's 1 meter, 2 meters, 3 meters. All right, and those are the ticks for the seconds. Okay, so that's 1 second, 2 seconds, 3 seconds, 4 seconds, and 5 seconds. Okay, so after 4 seconds, he would be here. No, wait. He would have walked 2 meters. Right, that's what we saw up there. 2 meters in 4 seconds. So from there to there. Okay. From here to here. Now after another 1 second, when he walked backwards, he walked 1 meter. So this would be after 1 second would be 5 seconds. So t equals to 5, and he would have walked another meter. And that point would be about there. Yes, that's the meter. So if I plot the graph, what would it look like? Okay, it would probably look something like that. Yeah, there we are. That's the graph. That's the distance. Now, let me just make sure that this is the distance and not the displacement. Now, distance. Okay, so far so good. Now, let's now think about making a graph for the displacement, right? Okay. I'm going to call this axis. I'm going to call this vertical axis X. I'm going to call the horizontal axis T. So T again is the time in seconds. X is in meters. Now this time I think of X as the displacement from 0. Okay, as the displacement from 0. So starting from 0, after 4 seconds, he walked 2 meters to there. So that's 2, that's 3, that's 1. So after 4 meters, he walked. After 4 seconds, he walked 2 meters. All right. But after another second number 5, he walked backwards. He walked backwards by 1 meter after 1 second. Now, if he walked backwards, the x value, alright, well, here, if I think of the x value here is 4, the x value there is 0. So when he walked backwards by 1 meter, alright, to there, alright, that would be 3. X equals to 3. Oh, oops, that will be x equals to 2. Alright, so from that point, he would, after 1 second, right, I missed out something. No, made a mistake, obviously. Right, that position there is for x equals to 2. Alright, he walked 2 meters, of course, not 4. I was confused with the 4 seconds. And after another second, he's back here, which is at x equals to 1 meter. So that's correct. That's the actual position of x. So after 1 second, he would be here. All right. At the 5th second, he would be here. And this graph would therefore look like this. You can see that it's quite different from the distance graph. This is the displacement graph. So x is the displacement. Because of the different meanings of displacement and distance, we have a different graph here. Next, let's think about the speed and velocity. Now, from these graphs, let's see how we can draw the speeds and velocity. I need another graph. It's time. Now this time I want the speed as P EED. Right, and that's in meters per second. And I have time in seconds down here. And the times are 1, 2, 3, 4, 5 seconds as before. 2, 3, 4, 5. What about the speed? How can we find the speed? Well, if we go back to the picture, you can see that in the beginning, when he start from 0 and walked for 2 meters, it took him 4 seconds. So clearly, the speed during this time, must be 2 meters over 4 seconds, which is 0.5 meters per second. And on his way back, on his way back from 2 to 1, he walked in 1 second, he walked 1 meter. So during this time, his speed is just 1 meter per second. Okay, so we have the two speeds here actually, and we can actually plot the graph of that. Now, but instead of doing it this way, quite directly, I'm going to do it using just by looking at the graph itself. Now, this is going to be useful if all we have is the graph, which happens quite often. So if looking at this graph, this graph, how can we tell the speed? Well, let's look at the first part of the graph. All right, this part down here. This is a straight line, and it tells us that in 4 seconds, this boy walked a distance of 2 meters. Okay, so 2 is the vertical distance. If you think about this line, 2 is the vertical, 2 meters is the vertical distance, and 4 meters is the horizontal distance. So, in other words, it means that the speed, since we know that speed is distance over time, what this picture tells us is that the speed is actually the same as this gradient. The gradient right, the gradient, as we see from this graph, is the vertical. This vertical divided by the horizontal. So the gradient is 2 over 4, all right, which you got from here, the 2 there and the 4 there. Right? So this is actually equal to the speed. And that's the speed between 0 and 4 seconds. So now we have the speed during this time. It is 0.5. Okay, this is 0.5 meters per second. Let me sketch that. Right. 0.5. So during this time, speed is the same over the 4 seconds until here. Now what happens between 4 and 5 seconds? Well, we know that he turned back and he walked faster. Alright, he walked at 1 meters per second. But looking at just the graph, looking at just this part of the graph, how can we tell the speed? It's the same, using the same idea. Let's look at this part of the graph and think about the distance he has traveled, which is the vertical distance, and the time he took, which is the horizontal amount along the graph. And you see that we need to take this vertical part, which is distance, and divide by the horizontal part, which is time. Okay, and the vertical part here, we know from reading the axis that it is just 1 meter. Horizontal part, again, from reading the axis, it's 1 second. All right, 1 second and 1 meter. So clearly we need to divide the distance by the time, which happens to be the vertical and horizontal. So once again, the speed is the gradient of this part of the graph. Right? And that gives us, that gradient there gives us 1 meter. It's just the speed. It gives us 1 meter per second. So I can plot that too. And that's 1 on the axis. And so over the 4 to 5 second period, I am here. I'm at 1 meter per second. So this is kind of the duration this time. So there I have the speed. It changes from 0.5 to 1 meter per second. And we have just learned that we can actually get that information from the gradient of the graph. Now, what about the velocity? Velocity is always a little bit more tricky because velocity has direction. So let's check this out. Now that's the time. Okay, and that's 5 seconds, 4 seconds, 0 seconds, and we are interested in the velocity in meters per second, but this time we have direction. Okay, so what happens in the beginning between 0 and 4 seconds? Okay, like before with the distance, we can make use of this part of the graph between 0 and 4 seconds and see that from in this 4 seconds, the x, the displacement, alright, change from 0 to 2, from 0 to 2. So there is a change in displacement of 2 meters. Alright, so this tells us that the velocity is 2 meters divided by 4. Once again, we have vertical divided by horizontal. So this gradient, therefore, this gradient tells us the velocity. Right, it's 2 over 4 meters per second, which is 0.5. So 0.5 is here. Now, but we have a velocity. So how do we represent the velocity? Now we are going to, if we look back at the picture. Now, when I took this as the x-axis, I have unconsciously assumed that it is positive to the right side and negative to the left. So in this case, the gradient, well, since when dividing 2 and 4, just got a positive number, so the gradient is just positive 2 over 4. So it's a positive number, meaning in this case going to the right, 0.5. So over this period from 0 to 4, the velocity is just 0.5 all the way. Now let us now look at the next part, this part here. Now this part it slopes downwards. There's obvious difference, and during this time, all right, this 1 second between 4 and t equals to 4 and 5. Okay, this is the time. This is the 1 second. 1 second. The x has changed. The x has changed by this amount there. Now it has changed by 1 meter. Right? You can see from here that there's a 1 meter change down here. Down here. Okay. So the speed, the gradient is 1 over 1, right, meters per second. That's also the speed. But this time, because the x decreases along this line, x decreases, so it's a negative slope, right? The change in x is negative. So therefore, this time our velocity is -1. Now we can plot, so we have to plot -1 on this velocity time graph down here. I call this -1. Then between 4 and 5 seconds, my graph looks like this. So clearly, there's a jump from up there to down here. So that's the velocity time graph.